So a quick lesson on determinants and inverses of a matrix, finding the inverse of a matrix. This could be used when solving using matrices. Um, we're not going to get into the details on how to get these things done. We're just going to look at how to quickly get through this with the use of the calculator. I find Desmos to be most useful. Uh, so every square matrix has a determinant. So it has to be a 2 by 2, a 3 by 3, a 4 by 4, etc. Found using the calculator. So I'm going to type in my new matrix, right? This first one is a 2 by 2. So I'm going to enter in my 6, 4, -1, and 0. And I'm going to hit enter. And then we see at the bottom of the matrix tools that there is a DET for determinant button, and then we just need to tell it what matrix we need it to find the determinant of. So for this first example, right, we a determinant of -4. Right, so we just enter the matrix and use the determinant tool. So if you want to, you can pause now and do this example here to practice. So you should have gone in, entered your new matrix, made it a 3 by 3, enter in the values, the elements of the matrix. That's the hardest part. I give it a quick glance to make sure that I didn't make any mistakes and enter that into the calculator. And then I say I want you to find the determinant of matrix B. And we get a value here of -8. Next concept is identity matrix. The identity matrix is the matrix that when multiplied by another matrix equals the same matrix. So the identity matrix, again, it has to be a square, and the identity matrix for all 2 by 2 matrices is this. Notice I entered the ones on the diagonal going from upper left to lower right, and I fill in the other values with 0. Right, so now I'm going to have a 3 by 3 matrix, ones on the diagonal, and then I fill in the remaining openings with zeros. And that's it for the identity matrix concept. To find the inverse of a matrix is the matrix that when multiplied by another matrix equals the identity matrix. Right, so we can multiply these two matrices, clear everything out. So I enter my matrices in. I confirm that everything matches. I could, at this point, just have the calculator tell me what is the inverse of A and then match it up to our other matrix in our example, right? So if I want to find the inverse of matrix A, I tell it matrix A, and then this button right here gives me inverse, right? So there's my inverse. The calculator will also convert that into fraction form for you. If I wanted to do what I'm being asked to do specifically, I can enter this other matrix in. -1/6, 1/3, and negative 2/3, right? And then when I go A times B, I see that identity matrix of 1, 0, 0, 1. The ones are on that diagonal. For example, the your turn part of example 2, go ahead and try that. You can either enter both matrices P and Q, multiply them and see if you get the identity, or you can enter P, which would be faster, and just have the calculator find the inverse of matrix P. So go ahead and give that a try. Looking at that part then, right? New matrix 2 by 2, 3, negative 1, 4, negative 2. Right, so I've entered matrix P, and I'm just going to have the calculator quickly tell me the inverse. Right? Do these match? Does my new work on Desmos match matrix Q? No, it does not. So those two matrices, right? Q is not an inverse. If I multiply them, I am not going to get the identity matrix. So for example 3, then, we're just using the calculator to find the inverse of your matrix. Again, it has to be a square matrix. And there are circumstances then when you will not be able to find the inverse because it doesn't exist. So let's look at our first example, negative 1, 0, 8, negative 2. Right? I enter that in. I tell it, hey, find the inverse of that. Right? So I would write over here, let's say that my inverse then is negative 1, 0, negative 4, and negative 1/2. If you wanted to leave that as a decimal, that would be perfectly fine as well. For the other one, negative 4, 6, negative 2, and 3. Tell the calculator find the inverse of matrix B. So for the second part of example 3, I have my matrix entered, and then I tell it, hey, make the inverse of matrix B. And you see I get the orange error message, and it says singular matrices do not have an inverse. So matrix B actually has a determinant of 0, meaning that you cannot calculate its inverse. So that is a possibility. So I would just write not possible over here, or no inverse, no solution, anything to indicate that it's just not going to happen. Right, so that is it for what we are going to do. Your assignment is here. It's built into the PowerPoint. So you should be good to go to get these 7 problems done and turned in.